All right, so net ionic equations. We just kind of need to make sure we understand what's being asked for here. So an equation, we know that we're going to have both sides and it has to balance out and equal. For in chemistry, we know the two sides are reactants and products, and we separate those with an arrow, our yield sign. So ionic means that we've got ions, cations and anions that are interacting in some way. And then net means, if we think about it, net just means what's left over, what remains. So if you have a job where you get receive a paycheck, then hopefully you receive a paycheck in any job you get, but you you get a net pay. So there's a gross pay, and that is everything that you get. That's your entire salary, what you've earned that week, whatever the case might be, whatever you clock in, clock out, or a flat salary that you receive. But then there's taxes that are taken out, and so there's a gross amount that you initially get, but you don't get all of that. What happens is some of that goes towards you, and then some of it goes back towards who's paying you. And there's something that does not make its way to you, a certain amount. And if you look on your pay stub, it'll say what your net pay is, and that's how much you actually get. The other monies, they're somewhere else, so they're not part of your pay. So here in a net ionic equation, we have cations and anions that are interacting in solution. So if you need to go back and watch that other video, there'll be a link at the end of this video about that. But hopefully you've already watched that before you went to this one, just on basic precipitate reactions. And then once that reaction occurs, then if the reaction occurs, because it doesn't always happen, when it does happen, some of it moves. Some of those there's a new compound that forms, that precipitate that falls out of solution, and that is where we're looking at the net ionic equation. All right. So I'm going to use the same examples I had in those other videos. All right. So we had calcium chloride, and it was a solution of calcium chloride, right? And it was mixed with some sodium nitrate. And it's a solution, right? And then we said we swapped everything out, right? So that means we know that sodium was now over there with chlorine, and we used our solubility rules. Plus, everyone kind of already remembers this anyway. And the table salt, sodium chloride, it's soluble. And then we also saw that the calcium is now displaced and replaced, and the calcium is now with the nitrate. And we saw that the calcium is all with the nitrate, that not all nitrate compounds are soluble. So we ended up having a phase label of AQ in this one. And so in this one, we wrote no reaction, all right? And so just the basics, without having to worry about ionic equations, this works. But we're going to go one step further now. So here's our reaction. Now, to do the rest of this, we do need a balanced equation. So in the other video, all we had was just the skeleton equation, because we were just worried about trying to identify the precipitate in the reaction and what was the new solution that was forming, right? Now to do this, we have to know exactly how many ions we're dealing with, particularly how many moles of it, right? So if we look at this, you see CaCl2. Well, there's 2 chlorines here, only 1 here, so obviously we need a 2, right? And so there's 2 sodiums here, right? And then 2 chlorines over here, so 2 sodiums, so we need a 2 right here. So right here is where we notice, oh, we have an error with this. So we know that this really has to be this. And in my mind, I was thinking that, I just didn't write it. But as I balanced out the reaction, I noticed it. So no need to stop the video and start. We caught the error. So if you caught this early on before I did, good job. Good job. So now we got a balanced reaction, right? So that's an A. Okay, that's an A. Okay, so what we have to do is we have to write out what's called the total ionic equation. And this gets a little lengthy. All right, this gets a little lengthy, but this is, you just have to do it. This is what's about being organized. So total ionic equation. So we have, what you do is you take each compound, break it apart into ions, because remember we had said that, all this was in solution, so all this was in a beaker or an Erlenmeyer flask, and this was in a beaker or an Erlenmeyer flask. So these ions are already separated. They're already in aqueous form. So the total ionic equation is let's take a look at what we started with. Let's take a look at where we're going. All right. So typically what would happen is this, for people who understand how to do this and don't need the precipitate reaction, we could have started from scratch. I could have given you a word problem where it says solutions of calcium chloride and sodium nitrate are combined together. Write the net ionic equation for this reaction and identify all the parts to it, which we're going to talk about here in a second. So we've already done the reaction, so we're sort of reverse engineering this. So in this beaker right here, solution 1, we have calcium ions and chloride ions. So we have calcium ions that are in aqueous form, and we have chloride ions that are in aqueous form. But there's a 2 right here. Don't forget, it has to balance out the total amount. Okay? And we have 2 sodium ions and 2 nitrate ions. Now, you don't have just 2 of them. These are moles of them, so there's a bunch of them in there, right? So remember, whenever we're talking compounds in a reaction, we're always talking about moles of substance. So that 2 means 2 moles of something. The 1 as a coefficient means 1 mole of it, right? So it's not that you have just 2 ions or 1 ion. So here we have 2 Na plus, and again, it was a solution of it, so those ions are in solution. They're in aqueous form. And we have 2 NO3, and of course, that's aqueous as well. So now we write a reaction arrow. So you see there's not going to be a lot of room here. So if you have enough room from one side to the other, you put this all in a straight line. In a situation like this, when you don't, you'll see this happen in textbooks as well. What you do is you drop down, you sort of come over a little bit about midway, and you write the rest of it going in this way, and it's understood that all of that is on the product side. Okay. So here we have 2 Na and 2 Cl, so we would have to put 2 Na plus, and of course that's in aqueous form, plus 2 Cl minus, and of course that's in aqueous form, plus, so we're going to bring that plus sign down. This is Ca, and remember Ca calcium, that is 2 plus and aqueous, so we see that, plus, then we see there's 2 NO3s, right? So that's 2 NO3 minus, and of course those are also aqueous. All right, so now this is what you do. Total ionic equation. This is the total ionic equation. Done and done. Done and done. So now we come over here and you look on both sides of the reaction. Okay? You look on both sides of the reaction. If you have something aqueous on the reactant side and it's aqueous on the product side, you literally put a strike through. You just get rid of it. So on the product side we have calcium, Ca2 plus over here, so put a strike through. There's 2 chloride ions on this reactant side and 2 on the product side, strike through. There's 2 sodium ions on the reactant side, 2 on the product side, strike through. And there's 2 nitrate on this side and 2 on this side. So what the strike through means is did not react. All right. So this right here just simply means does not react. That's all it means. So now you write the net ionic equation. I can't spell ionic. So the net ionic equation is what's left over. Well, there's nothing left over that came together to precipitate out. Everything stayed in solution on both sides, in the first beaker and then in the second beaker, because in the first beaker and second beaker, when they were mixed together into this one big container, this is over here, so this is the second solution we had, and this is all mixed together. Nothing happens. So there is nothing left over. So there's nothing left over to react and come together. So we literally, if you remember from the other video, we said no reaction. And I'm abbreviating reaction RXN. Okay, you should write REACTION, reaction. No reaction, all products are soluble. Pretty easy. All right, so now let's take a look at the second one. Okay, that second problem that we had on the previous video. If I remember correctly, see, we had barium chloride, BaCl2, and there were solutions of barium chloride, and it was sodium carbonate. And those were mixed together, right? And then you can see that the barium and the sodium displace and replace each other. So sodium is going to be over there with chlorine, and so, you know, of course, we're going to get NaCl, and of course, that's going to be aqueous. And then the barium is now over here with the carbonate, right? And then, so remember we had said, so carbonates are insoluble except when they're mixed with the alkali metals or ammonium. Barium is not an alkali metal, so this is not an exception to the rule, so it's insoluble, right? And so what we did was we came over here, we put that down arrow. Remember, the down arrow signifies that right there, the barium carbonate, that's the precipitate. All right, so now let's follow what we did up on that previous problem. So total ionic equation. So just like on the other one, to get the total ionic equation, you have to balance the reaction, right? So let's see, 2 sodiums over here, so we're going to need 2 sodiums over here. So now that means there's 2 chlorines over here. There's already 2 chlorines over there. Check. 1 barium, 1 carbonate, 1 carbonate. Balanced. All right, so total ionic equation. Remember, you write out everything that you have on both sides in all the forms that you have, right? All right, so what we've got is this. We've got Ba2+. And remember, this right here was a solution. There was solution 1. There was solution 2. So it's an aqueous form. And then that's 2Cl minus, right? And that's an aqueous form. Plus, there's these 2 sodiums, 2Na plus, aqueous. It is a lot of work, but you have to do all this. And then there's 1 carbonate right there, right? Because remember, carbonate is just CO3, 2 minus. So we don't write 1s, CO3, 2 minus. And again, right? Draw a reaction arrow. I don't have enough room on this side over here, so I can drop down, come over this way, and then start over again if I don't have enough room to make it all in one line. On a quiz or a test, you know, you'd have a regular 8.5 by 11 piece of paper, and you'll have plenty of room to go left to right. But if you don't, you can. And I could have scooched this over and done that. I just happened to start here, so I ran out of room. So if I'd have gone over this way, so I'll do it different. How about that? Well, let me go ahead and move this over here so you can, you'll have multiple examples. So you'll be able to see what it looks like if it's all on one line. All right, let me do that for you. All right, so now we see here we've got 2 Na plus, 2 Na plus. That's 2 Cl minus, right? That was a crazy looking 2. 2 Cl minus plus we had identified using our solubility guidelines that this is insoluble. It is not aqueous. So we're not going to use an AQ symbol right here, right? So we're going to write Ba 2 plus CO3 2 minus. Okay? So these two are going to end up coming together in the solution, right? So what that means is this. Okay, so what we said before was you then look on both sides, and whatever you have the same on the reactant and the product side, you put a strike through, get rid of it, right? So we see here that we have sodium is aqueous on the product and the reactant side. We can strike through that. We can see here that chlorine is aqueous on both the product and the reactant side. We can strike through that. But then we see here that the barium is aqueous when it was over here in solution 1, but now that it's mixed over here, it's no longer staying in aqueous form. It's going to come together with the carbonate and precipitate out of solution. So we're done now with the total ionic equation. So now what we have is our net ionic equation. Okay. We have our net ionic equation. So what that means is anything, what we do is what's left over. Then remember the net is what's left over. What remains. So what's remaining is barium 2 plus that is in aqueous form. So now we can think of it as being in a solution by itself. And we have carbonate that is aqueous, and we can think of it as being in a solution by itself. If we were to mix those two things together, we've already seen here that they come together and they precipitate out into barium carbonate. So this is our net ionic equation. So this is what we write. And so again, if you had a coefficient of 2 in front of any of these, or 3 or 4 or 6 or whatever, you would put that coefficient in front. Those coefficients don't go away because you have that many pieces and parts coming together. In this case, you have 1 mole of, if you look, you have 1 mole of barium ions, you have 1 mole of carbonate ions coming together to make 1 mole of these together to make 1 mole of barium carbonate, because they come together in equal proportion. You're going to get 1 mole of that, right? Okay, so almost done. Almost done. So now we have something that we refer to as, wow, let me spell that again for you. These are called spectator ions. So, sports analogies are overused. I try not to use them too much, but it does work in this case. So if you think of, pick any sport you like, it doesn't matter what it is. The people in the stands, they're spectators. They are not actively involved in what's going on. They're kind of in the back and not paying attention. They're not part of what is occurring. So if you think about it here, the ions, the cations, the anions that we have put strike throughs over, they are not actively participating in the chemical reaction. They're just not. They're staying in solution. So the spectator ions are our sodium ion, because they stay in solution, comma, and then we had our chloride ions. Now, notice sodium has a 2 on this side and a 2 on that side, so I'm going to put a 2. The chloride ions have a 2 here and a 2 here. I'm going to put a 2 to represent that I have 2 moles of each ion remaining. Whatever the coefficient is, you always use it. So remember, just as a note, remember spectator ions. They basically, these are the ions that remain in solution. And that's it. This is, if you're ever asked to do anything with net ionic equations, this is basically where you start. You do what we did on the previous video, which was take a look at the reaction using the solubility guidelines and figure out what does and doesn't react, what the precipitate is. If there's no reaction, you write no reaction. You got to precipitate, put the down arrow. And then from there, you mark out, basically, you're basically marking out your spectator ions when you put a strike through. Okay. What's not actively part of the reaction. And then what we do now is just list, we're just listing everything out. Total ionic equation, the net ionic equation, and what are our spectator ions. And then that's it. And then there'll be another video where we'll do some stoichiometry with this stuff, which, that just brings us back to basic Chem 1 stuff, where if you're told you got so much of this, do some math to figure out how much of that you got. That'll be easy. So, and I'll use these same reactions again just to kind of keep that theme moving forward. I don't have to use a new reaction. We can just take these same reactions and just keep moving, and building on it. All right, and that way, hopefully, that'll help keep everything organized for you as far as thinking about all the different problems you got. No matter what solutions you're working with, this will always work as long as you read your solubility guidelines correctly. This will always work. All right. So stop and rewind, and again, I will leave down in the description below, I will leave timestamps for you so that you can navigate back and forth in this video fairly easily on the different topics that we're studying in this video, so that you can easily kind of go back and forth and get what you need out of this. Take care. Hope this helped. Bye.